Hello, everyone. I hope you are all having a wonderful afternoon or evening. We are going to look through our homework for this evening. I'm going to start with 13. That's asking us the perimeter, and it gives us a nice little hint here. This is the distance around, which we learned back in the 4th grade, the difference between perimeter and area. Perimeter is the sum of all the sides, while the area is the product of the length and the width. And we got some interesting information here. So we're told that 66 is the total. So I'm just going to put 66 in there. And I'm going to use units here because I'm not given a specific unit. I'm also told that DC is twice as long as CB. So I don't know what those are, but I know that if these little sides are X, these must be double those. Now I'm going to use my information. I'm going to use the sum of all my sides. So 2X, 3X, 5x and 6x equals 66. Divide by 6 to find x. And on our assessment, we'll have a similar question. And many people are going to answer this as 11 and forget that the question we are asked here is, how long is AB? And so I actually have to substitute 11 in for x to get the length of AB as 22 units. In 14, we're getting into some proof language. We talked a little bit about proofs, and we've talked a little bit about, in our first few days of geometry, what this symbol means. So this congruent symbol tells me that these segments, XS and segment YT, if they are congruent, they're the same size and they are the same shape. So what I like to do is, if I know XS and YT are both congruent, I'm going to go over to XS, which is this diagonal, put a tally mark there, 1 tally, and then it looks like 2 now, so I'm going to make that 1. These two are exactly the same, so I use 1 tally for each, so I remember that I was given that information. The second set tells me that YS is congruent to XT, so again, I'm going to tally those up. I'm going to use 2 tallies now because those are different segments, however they are congruent. And then I'm given some information here, so the first piece of information I'm given is XT is 2r plus 5. I'm actually going to move this over a little bit. So this is 2r plus 5. XS, this diagonal right here. This diagonal right here, I'm going to outline in black, is 3m plus 7. I need to move this over a little bit because I can't see it. YS is 3 halves r plus 2. And then I have 4 2/10 m plus 5 for YT. So my other diagonal is, I'm going to write that right up here just so I don't forget. I'm going to use red for this diagonal, 4 2/10 m plus 5. All right. Directions say I've labeled everything up. Solve for R and M. And I'm actually going to do my work underneath the picture because I can't figure out a way to show all my work up here. And so I think I'm going to go after M first. We know congruency means that they have the same size and same shape if they have the same size. What I can do is I can set both of these expressions equal. So I'm going to take 4 2/10 m. Set that equal to 3m plus 7. I forgot the 5 up here, plus 5. Subtract 3m first. 4 2/10 m minus 3m is 1 2/10 m plus 5 equals 7. Subtract my 5 to get 2. Divide by 1 2/10. I typically love to work with fractions a little more than decimals. So one thing that might be simpler for you is I could think of 1 2/10 as 6/5. And I can multiply by a reciprocal. And now I have 10 over 6. And I'm going to reduce that and get an m will be divide top and bottom by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. So I've got m. It asked me to solve for m and r, so now I'm going to go after r. And so I've got these two values up here. I'm going to take this, hopefully you have that, shrink that down a little bit, come back here, and now I'm going to attack r. Again, both of these sides are congruent. Congruent is same size and same shape. So 3 1/2 r plus 2 equals 2 r's plus 5. Subtract my 2 r's. Subtract my 2. I'm going to think of 1 1/2 as 3 halves r. Both are equivalent to 1 5/10. And 3 halves r equals 3 multiplied by the reciprocal of 2/3. R gives me 6/3, otherwise known as 6 divided by 3 is 2. Oh, that was good. So, let's take a look at number 15. Given that our two angles are congruent, I love it. So let's tally this guy up. Tally, tally. And I am told that angle 1 is equal to x plus 4t, and angle 2, y minus 3. And it's asking me to solve for y in terms of x. Well, what I know here is that if these two angles are congruent, I know that these angles are the same measurement. So let's set them equal. And I have to get this as an equation of y in terms of x. So I'm going to add 3. And there it goes. 16. If angle POA is a right angle and angle POC is 3 times as large. So POA is a right angle. I'm going to put my right angle notation in the corner. And if POC is 3 times as large as COA, so here's POC. We had a problem similar to this. And here's COA. 3 times as large, if I call this x, 3 times that would be 3x. And I know the sum of these two angles, so 3x and x, is equal to the 90-degree angle. $90 divided by 4 in my head, what I'm thinking is, I know what 90 divided by 2 is easily, 45. I'm going to divide that by 2 again, because divided by 2 twice would be the same as divided by 4. So I get 22.5 degrees. So that's what my brain's thinking. The problem with answering this as 22.5, which will be the common mistake on our unit assessment, is that they're asking me for POC, and POC is 3 times x. So 3 times 22.5 degrees. And I know that 3 times 22 is 66, and I know 3 times 5/10 is 1.5, so that gives me to 67.5 degrees is the measure of angle POC. Very good. We had 2 more problems that I'm going to go through really quickly. Angle P is acute, so we know that angle P has to be less than 90 degrees. And if we think about 3x minus 60, must be less than 90 degrees. And so if I add 60 degrees, and divide by 3, x is less than, I know that 3 times 40 is 120, and there's 30 more, so I need 30 more, which would be 3 times 10. So if I don't know 150 divided by 3 right off the top of my head, I can break that down, but 15 divided by 3 is also 5, and so I know that x is to be less than 50 degrees. Anything bigger than 50 would make it a right or obtuse angle. Last but not least, we have a straight angle. We learned that this straight angle SRT, this whole angle, is 180 degrees. I'm going to write that above it. 180 degrees. And we're told that we also have some right angles. That's awesome. So we have a right angle here, which means that the other one's also right because it has to equal 180. And TRS, the big angle TRS, is 3x plus 3y. XRS, this guy right here, I'm going to do a huge angle here, is 3x plus 3y. So we've got two equations. I'm sorry, this one should have been 2x plus 5y. We have the 2x plus 5y, which equals 180, and then 3x plus 3y, which equals the 90-degree angle. So 2x plus 5y equals 180. 3x plus 3y equals 90. I want to use elimination, so I'll probably go after the x's here, times by -3 and +2. And I chose to do -3 and 2 so that they would eliminate, having opposite signs. -6x minus 15y equals 3 times 100 is 300, 3 times 80 is 240, so that gives me -540. 2 times 3x is 6x, 2 times 3y is 6y, 2 times 90 equals 180, and that gives me -9y equals -540 plus 180. I'm going to think of the 180 as a 200, so -540 plus 200 would give me -340, and then I'll put the 20 back to get -360. Divide by -9. Two negatives make a positive, and 36 divided by 9 is 4, so I would have y is 40. So I got y. I'm going to substitute the y back in, probably right there. And work my way through. 3x equals -30, so divide by 3 and x equals -10.